Today we have another question about related rate. So this question is written here: a swimming pool with a rectangular surface. The surface is rectangular and 18 meters long and 12 meters wide, 18 times 12, and being filled at a rate of 0.8 meters cubed per minute. So it says that at one end it is 1 meters deep. So this end 1 meters deep. The other at the other end is 2.5 meters deep. So total depth of the other side is 2.5 meters all together, with a constant slope. So this slope here is constant between the ends. The question asking how fast is the height of the water rising. How fast the height of the water rising means we need dH over dt, all of the water at the deep end, when the depth of the water, if the depth of the water at the deep end is 1 meter. So the height here is 1 meter, and there is an empty space here which is 0.5 meters. All together is going to be 2.5. This is 1 meter. The rate of filling is 0.8 meters cubed per minute. So what's happening here, there's already an amount of water inside, and this amount of water, I made it like a prism but a different way. So I count this width, which is the same width at the top as the height of the prism. So this width is the same like this, and the area which is going to be the base of the prism is going to be changed. That's a changeable area. So the area is changed. So this is actually the triangle. I take it from here. There is 1 point altogether is 1.5. So this is 1, this is 0.5. Altogether is 1.5 from here to here. And this is the base. This is the base. That's the base of the prism. And the height of the prism is constant. This is the width of the pool, so it's constant. So if I take the slope, which is for this angle, if I want to name this angle theta, for example, and its opposite, which is 1.5, divided by the adjacent, which is 18. So I got the slope equals to 0.083. Now, what I want to do, because I am trying to find the volume, increasing the volume, so I need to have the volume of this piece, which is the volume of the prism. To have that, since the area is changing, because as much as we fill this, the area is changing, but the height, which is the width of the pool, is staying as it is. So the area is changing. So I got the slope, but I want to find the relation between the base and the height together. So I have the slope 0.083. I will write down the slope equals to the height. This is the height, which is the height, it's going to change, and this is the base also changing. So this is the base here. I can say that this is the base and this is the height. This piece is the height changing. This piece is height, this piece is base changing. But because I have the slope value already, I took it from here, so I changed it here and then wrote down that the base comparing to the height is going to be given by this relation, substituting the slope 0.083 and h over b, and that's going to give me the base. Why I am doing this? Because I want to have one variable when I count the volume of the prism. So now I am coming back here. I will say that the volume of the prism is the base times the height. Well, the height of the prism, as I said, it's the width of the pool, because I took it this way. So this is the height of the prism. The width, this is constant. I'm not going to change it. The base is changeable, which is the base, since it is a triangle. So I have half of the base of the triangle times height, and this is the base of the triangle, as we said. This is the base of the triangle, and this is the height of the triangle. So in order to have one variable, and I put this guy, this h here, and I just replace, and 1/2 is here. So this is 1/2, and this is the h, this is the w. I'm changing the b with the value I got it from here. So that value is b equals to h over 0.83. So I substituted multiplying b. Instead of b, I put h over 0.083. So I multiplied h times h is h squared divided by this. This width was 12 meters. The width is 12 meters. H times H is H squared. And then now 12 times 1 over 2, I put it here. Denominator is the same. Now 12 over 2 is 6. I put this guy outside, so I got a relation of the volume of the prism in terms of one variable, which is H. Now I am taking the derivative with respect of time, not the derivative of V with respect of H, with respect of time. So this is a related rate, so I take the derivative. This is going to be the constant when you divide 6 by 0.083. And now I take the derivative of H squared. So it is 2H to the power of 1 dH over dt. 2H to the power of 1, even if you don't write down 1, that's fine. H to the power of 1 dH over dt. Now, multiply 2 by 72.29, I got 144.57. And I have this H. What was the H when we started? It says the question saying that when the end, deep end is 1 meter. So I put 1 meters here. That's a multiplication. I need this guy, which is dH over dt. So I have everything, and I have the rate of the change of the volume for this pool, which is given in the question. So I'm just going to divide 0.8 by this value, which is 144.57, and I get the value of 0.0055 meters per minute is the change of the height in the deepest end of the pool. So this is one of the important questions that we need to explain in related rate. Thank you so much. Thank you.